Hello class, today we're going to talk about multiplying mixed numbers, again with a twist. So this will be day one of a 2-day lesson, so there will not be any homework today. So please make sure though that you have the addition and subtraction completed by 11:59 tonight and submitted online. Okay, please remember you have to submit those via Google Classroom. There was a video in yesterday's lesson that talked about how to do that, so please remember. Okay, so please get that done. So today we're going to talk about multiplying mixed numbers. So what you're going to need is your Chromebook, your daily notebook, your pencil or pen, and you do need to take notes. So every time I pause the video, you need to answer the question and then turn the video back on so that you can see me work it. So let's get into this lesson today. So by the end of this lesson, you should be able to do a couple things. Okay, the first thing is you should be able to hopefully multiply positive and negative mixed numbers. But if we don't get to that during the first day, we will certainly get to that during the second day. Okay, so what I'd like for you to do, I want you to answer a warm-up question real quick first. Okay, and this one says, 4 friends had a competition to see how far they could walk while spinning a hoop around their waist. The table shows how far each friend walked. So I want you to answer question number 1. It says, how much farther did Lauren walk than Rosalind? So use the table at the bottom right of the screen to answer this question. It looks like you might not be able to see it because of the video screen, so let me turn off my webcam just for a second so that you can see those fractions, and then pause the video and answer question number 51, please. Okay, so let's see how you did. Okay, I'll turn the webcam back on in just a few moments. So in this particular one, it says, how much farther did Lauren walk than Rosalind? So we got to come down here and look at Rosalind and Lauren. So here is Rosalind, here is Lauren. So we're looking for how much farther did Lauren walk than Rosalind. Okay, so basically what this is we're taking Lauren and we're going to subtract Rosalind from it. Okay, so if we were to take Lauren, which is 2/3, we're going to subtract Rosalind from it, which is the 1/8. Well, again, since these are just simple fractions, we still have to find common denominators no matter what. So we still have to rewrite with common denominators. So we start at the 8 and we start going through our multiples of 8. 8 times 1 is 8. Can I turn the 3 into an 8? No. 8 times 2 is 16. Can I turn the 3 using multiplication into a 16? No. 8 times 3 is 24. Can I turn that? Well, of course, since you did 8 times 3. So 24. Okay, now we change our numerator. What did I do this 3 to turn it to a 2? Turn it into a 24, sorry, multiplied by 8. So I multiply the 2 by 8 to get 16. What did I do this 8 to turn it to a 24? Times 3. So 1 times 3 is 3. And now we subtract. 16 take away 3 gives us, let's see, was that 13 over 24? And then we ask ourselves, can I simplify that? And 13 has a 1 in the 13. 24 has a 1, 2, 3, 4, 6, 8, 12, and 24. Okay, so the biggest one they have in common is a 1. Okay, so now the last thing that we got to think about is what kind of a label. Since this is a word problem, we need to have a label on it. So the question says, how much farther did Lauren walk than Rosalind? 13/24 of a mile, because our label is miles. And that's how we did the warm-up question for today. So why are we still doing this kind of stuff? Well, again, it says we got to add, subtract, multiply, and divide rational numbers fluently. So we got to make sure that we understand how to deal with rational numbers and fluency of doing those. That means that you've got to be really, really good at it. Well, today we have a pre-lesson. Okay, so the pre-lesson today, let me turn my little webcam back on so you can see me here. There we go. So the pre-lesson for today is actually remembering how to change a mixed number into an improper fraction. Okay, so that's what we got to understand how to do. So it's how do you change a mixed number to an improper fraction? Now, many of us throughout the last week or so, you've told me that. Because when we started addition and subtraction, one of the things you wanted to do was just change your mixed number to an improper fraction, and we used the popcorn method to do that. Okay, so what is the popcorn method? Well, the popcorn method is something very simple. It is nothing but take your denominator, multiply your whole part by that, so denominator times whole, plus the numerator, and you put it back over the denominator. So in this one, we would do 3 times 4, which is 12, plus 2, which gives you 14, and we'd put that back over the 3. Now, what's actually happening when we do that? So let's go back and look at, whenever I'm actually doing that popcorn method, what am I doing picture-wise? Well, if I were to draw a picture of 4 2/3, here's 1, 2, 3, 4, and then one more out there. So here is 5 things, but I need to look at 4 2/3. Okay, so there's 1, 2, 3, 4, and I need 2/3 of this one. Okay, so there is 2/3, and you can barely see this one, but you can kind of tell what it's supposed to look like. So, and if I were to shade all that in, that would be 4 2/3. Well, what we really do whenever we, and I'll go ahead and shade that in to make sure that you know what I'm talking about. So what we're really doing whenever we do 4 2/3, and when I do this 3 times 4, 3 times 4 gives us 12. I'm taking these 4 whole pieces and I'm chopping those into thirds as well. So how many thirds would I have when I do 4 times 3? I would have 12 of them. There's 3 and 6 and 9 and 12. And then when we add the 2 on, we end up with these 12 plus 2 more, okay, which gives us 14. So that's where the 14 comes from. And then what size piece are they? They're all thirds. So that's really what you're doing when you do this popcorn method. And that's what I need you to really understand, okay, that's the reason why that works. Okay? So with that in mind, what I'd like for you to do is pause the video and use the popcorn method, denominator times the whole number, plus the numerator, and put it back over the denominator. I would like for you to change each of these mixed numbers into their corresponding improper fraction, please. Okay, so let's see how you did. So hopefully you did 5 times 9, which is 45. And then 45 plus 3, 45, 46, 47, 48. It's 48, and you put it back over the 5. So 9 3/5 as an improper fraction would be the same thing as 48 over 5. Well, what if I did 6 7/9? Well, the 9 times the 6 gives you 54 because you multiply those. You add the 7 to that. So 54, 55, 56, 57, 58, 59, 60, 61. And you put that back over the 9. So that would be 6 7/9 as an improper fraction. Okay, so that's the prerequisite skill to be able to do today's lesson. You've got to be able to change a mixed number into an improper. And we'll find out why in just a few minutes. Okay, so let's dive off into this lesson. Now, if you remember back in integers, that there were a couple times where I insulted your intelligence. I'm going to do the same thing today with fractions because I need to build a concept. Okay, so here's our first multiplication problem of fractions. It says, what does this problem mean? Now, I know some of you are going to say, well, Mr. Nash, well, it says 1/2 times 1/2. You're right, it says that, but I said, what does that mean? Okay, so in order for us to determine what it means, then we need to actually write this out in a language arts format. This question right here, what it really means is what is 1/2 of 1/2? That's what it really means. It asks us a question. What is 1/2 of 1/2? Well, if I were to look at this in terms of a picture, well, so here is 1. Well, I only need 1/2 of it. So here is 1/2. And what I want to know is what is 1/2 of 1/2? That's what my question is. So if I look at this half, I need 1/2 of that. That means I got to chop this in half. So I really need that much right there. Well, what is that in the grand scheme of things? Well, if you were to look at that right there and I were to chop this up in the same thing, that is how much of that whole piece? That is 1/4 of that whole piece. Okay? So what is 1/2 of 1/2? 1/4. Okay, well, if that's the case, then let's look at another one. What if I gave you this one? So what does this one say? Write down the question real quick. What does this one say? Okay, hopefully you wrote down the question that says, what is 1/4 of 1/2? Because you'll notice that this is the first fraction we talk about, and I want to know what is 1/4 of that. All right, so what is 1/4 of 1/2? Okay, or you could say what is 1/2 of 1/4? Either way. Okay, so let's see about that. Okay, so if I were to do that, here is again my 1. Okay, so it says what is 1/4 of 1/2? So I need to see what is 1/2. Okay, so here's my 1/2. There it is right there. What is 1/4 of 1/2? Now what I need to do with that, okay, is I want to see what is 1/4 of that. So that means I need to take this 1/2, chop it into 4 pieces, and take one of those pieces. Okay, now if I were to say it the other way, what is 1/2 of 1/4? Well, if I took the 1/4 right here and did half of it, same thing. Okay, so that means I need to do the same thing over here. And in the grand scheme of things, what is that amount of the whole? That amount is 1/8. Okay. Now, with that in mind, what does it appear that we're doing? What does it appear that we're doing? 1/2 times 1/2 gave me 1/4. 1/2 times 1/4 gave me 1/8. What does it appear that is happening? What appears that's happening is that I'm just taking my top numbers and multiplying them, taking my bottom numbers and multiplying them. Interesting. Okay, so what if I were to give you this one? Okay, well, this question says, in one of two ways, you can write it, what is 1/2 of 2/3? Or you could say, what is 2/3 of 1/2? Either way will work. Okay? So what is 1/2 of 2/3? Well, if we do it like what appeared to be happening in the two previous questions, what do you think my answer is going to be? My answer should be 2/6. Well, let's see if our picture actually models that. Okay, so again, and I'm going to change my color again. Okay, so I've got 1, and this says I've got 1/2. And it says, what is 1/2 of 2/3? Okay, so what is 1/2 of 2/3? So I need to actually make 2/3 first. So here is cutting into thirds, and I've got 2 of those. And I want to know what is 1/2 of 2/3. Well, 1/2 of 2/3, well, 2/3 is 2 of those pieces, and I need 1 of those because I need 1/2 of it. So what is that in reference to the whole thing? Well, the whole thing is 1/3. 1/3. But I thought our answer was 2/6. Oh, if we look at 2/6 and we simplify that, I could divide this by 2. I could divide this by 2. I still get 1/3 is my answer. So what does it appear that we're doing if we have fractions? If we have fractions, what it appears is that we do top times top, bottom times bottom, and we simplify. Well, there's a little wrap that kind of helps us understand what it is that we're doing. So what I'd like for you to do, I want you to pause the video and write this down in your notes. And then I'll tell you what it says. Okay, so now let's find out how do we do this little wrap then? Well, this is what I call the multiplication wrap. Multiplication fraction wrap. It's real simple, real easy. Kind of goes like this. To multiply fractions, you know you got them. It's top times top and bottom times bottom. Just like that. Now, I know that kind of sounds silly, and I don't rap very well, but it does help you understand what to do. First thing says, to multiply fractions. Well, that is a conditional statement. The only thing we can multiply are fractions. So that means fraction, fraction, fraction. I can multiply fractions. So that first step is you must have fractions. You know you got them. So I know I got them because I just said I had them. It's top times top, numerator times numerator, and bottom times bottom, denominator times denominator. And then last but not least, we know we're going to simplify. So again, it goes like this. To multiply fractions, you know you got them. It's top times top and bottom times bottom. Word. And then simplify. That's the word. So let's see if we can actually do this with a mixed number. Okay, so what if I have this? This is what we've got. So we have this kind of a problem. 3 3/4 times 2 3/5. So we go through our wrap. To multiply fractions. Uh-oh. Do I have fractions? No. These are mixed numbers. So does it say to multiply mixed numbers? No, it doesn't. We don't have a separate mixed number one. We just have a fraction one. And it says to multiply fractions. Well, if you remember back at the beginning of the lesson, we talked about how to change a mixed number to a fraction. We use the popcorn method. Because the only thing that we can multiply are fractions. So could I take these mixed numbers and turn them into fractions? I sure can. All I have to do is do the popcorn method. So here we go. Write this problem down. Make sure you're taking notes on this, because this is what your assignment's going to look like tomorrow. So 4 times 3 is 12. Plus 3 gives you 15. And you put it back over 4. Times, do the same thing to the other one. 5 times 2 is 10. Plus 3 is 13. You put that back over the 5. And then you multiply. Now, this is kind of some tough multiply, so we're going to work this one 2 ways. We're going to work this the multiply way, and then we're going to look at it in a separate way. Okay? So the first thing I need to do is 15 times 13, and then 4 times 5. Well, I'm going to do the 4 times 5 first, because, you know, it's the easiest. And then I'm going to come over here to the side, and I'm going to do 15 times 13. Because I can't do that in my head. Or I could, but I'm not going to. So 3 times 5 is 15. And then 3 times 1 is 3, plus 1 gives you 4. And then I move over a spot. 1 times 5 is 5. 1 times 1 is 1. And I got 5, 9, 1. So I end up with 195. So I end up with 195 over 20. Now, if you give me that as an answer, you get half the points. Because that is a correct answer. However, it's just not fully correct because it's not simplified. So now we got to simplify. Now, in order to simplify this, we've got to figure out what do these two numbers have in common. Or better yet, since it's improper, we can divide first. So 195 divided by 20. Well, 20 doesn't go into 1. 20 doesn't go into 19. So how many times does 20 go into 195? Well, let's see. See, 20, 40, 60, 80, 100. 20, 40, 60, 80. So it goes 9 times. And that gives me 180 for my answer. And then I subtract. 5 take away 0 is 5. 9 take away 8 is 1. So we end up with 9 and 15 twentieths. Now, am I done? Not quite. Again, if you get this far, you get half the points. So now, I got to realize that the 15 and the 20, they both have a 5 in common. So I could divide this by 5, divide this by 5, and I'd end up with 9. And then 15 divided by 5 is 3. And then 20 divided by 5 is 4. And there's my final answer, 9 3/4. Now, I'll be real honest. I personally, because of the math I know in my head, I would never end up with 195 over 20. Okay? But that is one way that you can do this problem. Multiply and then simplify your answer. Well, what I'm about to do is I'm about to show you a second way of working this problem. Now, again, this was 12, 13, 14, 15 over 4 times, and then 10, 11, 12, 13 over 5. Now, you can get fractions and then simplify your answer, or you could actually simplify your problem. Okay, so here's how you do that. If I have any number on top and any number on bottom that have any common factors, I can actually do the division within the problem itself as opposed to doing the division in my answer. Okay, so I look here and I see this 15 and I see this 5. They have a common 5 in common. I could divide them both by 5. So if I were to divide this 15 by 5 and divide this 5 by 5, this 15 divided by 5 is going to turn into a 3. This 5 divided by 5 is going to turn into a 1. Now, in this particular problem, that's all we can do. But if you had other numbers that could simplify, then you could simplify those as well. And now we multiply. So now instead of doing 15 times 13, I'm actually only doing 3 times 13, and I can actually do that in my head. I know that's 39. And instead of doing 4 times 5, I just have 4 times 1, which is 4. Now, remember that big old ugly number we had, 195 over 20? Well, would you rather have 195 over 20, or would you rather have 39 over 4? Because I can do 39 over 4 in my head. How many times does 4 go into 39? 9 times. 9 times 4 is 36. We subtract out, and we end up with 3, and then the 4 comes along for the ride. That's the way I would actually do this problem. So there's two ways of simplifying. You can either simplify the answer, or you can simplify the problem. It's going to be your choice. And I would highly encourage you to simplify the problem, because that is a very strong algebraic concept that we've got to be able to understand how to do. So we're going to work one more problem for today's lesson, then we're going to call it a day, and then the rest of it we'll finish up tomorrow. So let's see if we can do this one. So we got 5 2/5 times 4/9. So the first question we're going to ask ourselves is, do I have fractions? Because the only thing I can multiply is fractions. So I ask myself, do I have fractions? Well, this first one, not a fraction. Has a fraction part, but it's a mixed number. So 5 times 5 is 25, plus 2 is 27 over 5. Now it's a fraction. Times, now is my 4/9 a fraction? Yes, it is, so I don't mess with it. 4 over 9. So, to multiply fractions, I know I got them. All I have to do now is top times top and bottom times bottom. So you could do it the long way and do 27 times 4 and get an answer. Something like, let's see, 7 times 4 is 8, carry the 2, and then 8, 9, 10, 108 over 45. That would be your problem. Now, I'll be real honest. For me, I would never get that. But you can, and then you simplify it. So let's look at simplifying the problem, because that's what I really need you to understand how to do. Do you see any numbers on top and numbers on bottom that share common factors? I hope so. The 27 and the 9. They share a 9 in common. So I could divide this by 9. I could divide this by 9. My 27 divided by 9 turns into a 3. My 9 divided by 9 turns into a 1. And so now instead of doing 27 times 4, I really only have 3 times 4. And 3 times 4 is 12. And instead of doing 5 times 9, I really have 5 times 1, which is 5. Now, I think I can probably simplify this one in my head. How many times does 5 go into 12? Twice. 5 times 2 is 10. I take out the 10 from the 12. What do I have left? I have 2. And what size piece are they? 5. So we end up with 2 2/5. And that's how we multiply fractions. So what I need you to remember for today is we have a little rap that helps us remember what to do. And this is what it says. To multiply fractions, you know you got them. It's top times top and bottom times bottom. Word. And the word is simplify. So until tomorrow, when we finish up this lesson, you have a wonderful day.